All right. So this is our last lesson today for unit 2, section 3.1, 3.3. All right. Now we've been focusing on acceleration the last half of this unit. Up there, I have our 3 equations that involve acceleration. Right. Now, if I look at each equation individually, they're labeled 6, 7, and 8 because that's what they are on the side of the board. If I look at each equation individually, they all are telling us something specific about acceleration or have a specific stipulation for acceleration. That first one, what is that first one finding? Acceleration. But what kind of acceleration? Average. Good. This finds an average, not mediocre, an average acceleration. That's a little joke. There you go. Right to the name. Okay. That's finding average acceleration. Caleb, you're second. B+. Okay. Does that make sense, guys? The reason why it's finding an average acceleration, it's finding our change in velocity. So if I had a graph that looked like this is my velocity versus time graph, right? My change in velocity is the difference between those 2 points, isn't it? Right? So I'm actually finding that acceleration. Okay? When I use that equation. All right? Does that make sense? Okay. Now, what do these other 2 assume about acceleration? What do these other 2 assume about acceleration?
All right.
Okay. Come here. If I graph this on a line, on my axis, what does it look like? If I graph this on the axis, what does it look like? It's a line, right? It's a straight line. Okay? What's the change on a velocity versus time graph? What's the change in a velocity versus time graph? Acceleration, right? The slope is my change, right? Right? So that's my acceleration, isn't it?
Yeah.
What can I say about my slope or my acceleration on the v versus t graph I drew? What can you say about the slope or the acceleration? It's what? Positive, and it's constant. So this equation assumes a constant acceleration. What about this equation? Does this assume a constant acceleration?
I don't think so.
Both of these equations are assuming we have a constant acceleration. What?
Are that equations going to be on the board?
Yep.
God.
Okay. Kyle, pay attention, please.
I'm trying to.
Okay, now you're doing a review. Okay. Those equations are assuming a constant acceleration. Now, if our acceleration is constant, that means this acceleration right here, is it still average or is it also instantaneous? It's also instantaneous, right? So if I'm assuming a constant acceleration, then this equation no longer finds an average acceleration. It just finds acceleration. Okay? We don't have to say average anymore because if acceleration is constant, average is instantaneous, right?
Yeah.
Right? They're the same. Does that make sense?
Yes.
Now, equation 8 is just like what equation up here? Except it has acceleration in it. Number 5, right? 5 and 8 look a lot alike, don't they? I left a big opening right here. Why do I leave a big opening right here?
So you can write something?
So I could put acceleration there, couldn't I?
Yeah, you could.
But in 5, what am I assuming about my acceleration? That's constant. There isn't any, right? Right? Because in 5, this will make, if I make a distance versus time graph, right? 5 will make a straight line, won't it? So if I have a straight line, is my velocity changing? No. My velocity isn't changing. What do I know about my acceleration? There's none. So really, 5 and 8 are the exact same equation, except for 5 has acceleration of 0. Right? If acceleration is 0, what's constant in 5? The velocity. Okay. So v is constant in 5. So on our list of equations, okay, this equation, d equals v naught t plus d naught, okay, this equation is assuming a constant velocity because it makes a straight line, right? If velocity wasn't constant, then we'd use equation 8. Right? So really, I don't really need a v naught here. I can just have v. Because v is constant, doesn't change.
What not makes it fancy.
It does. Makes it look really smart, doesn't it?
No.
So, does this make sense?
Yeah, I got it.
Now, what do all these equations depend on? Every one of these velocity equations, what do they depend on?
Letters.
Okay, they all depend on numbers and letters. Great. Okay. What's one letter besides acceleration, okay, that we see in each one?
Time.
Time. Time is in every one, isn't it?
Yeah.
Might it be useful to have a timeless acceleration equation? Might it be useful to have a timeless acceleration equation?
What scenario?
An acceleration equation without time. Okay, let me give you a scenario. You're a police officer, right? You were investigating an accident scene to try to figure out who's at fault, right? You have skid marks going in perpendicular directions. So like someone's coming from left to right, and they get hit by someone going, kind of front to back, or change it. Someone's going east to west, and they get hit by someone going north and south. Okay, does that make sense?
Yep.
Okay, you have skid marks in perpendicular directions, right? How could you figure out the car's initial velocities? Were you there to observe the accident? No. Were you there to time the collision? Were you there to time their braking? No. So you need to figure out initial velocities. There obviously was an acceleration because we have skid marks, don't we? What do skid marks tell us?
Just trying to slow down.
Changing speed, right? Someone was probably hitting the brakes, weren't they?
Somebody's probably
Okay.
gonna stop.
Hopefully they recognize they had to hit the brakes a little sooner than usual because that plays a big role in how hard the collision is, right? But if you have skid marks on the ground, right, that gives you some important information. What do those skid marks give you? How long it took to stop? Distance or time? Distance, right? No one was there with a stopwatch. You can't time how long they're braking for. Now some cars have computers that will actually do that now, which is kind of cool. Makes it a little easier for cops, right? But I can't time it. I have skid marks on the ground, right? So I have a distance. I know their final velocities are what? 0, because they probably hit each other and stopped, right? I can assume accelerations based on how big the cars are, okay? And typical brakes all cause about the same acceleration, okay? Higher quality brakes will have larger accelerations. Lower quality brakes will lead to smaller accelerations. And I can't talk to you. All right. All right. So if you have really good brakes, you'll have a larger acceleration in the opposite direction. If you have really bad brakes, you have a smaller acceleration in the opposite direction. If you have really old brakes, same thing, smaller acceleration. That's why it's better to have new brakes. Right. So we can assume accelerations based on the brakes, right? So we know acceleration, we know a distance, we know final velocity, we know initial velocity, but we got to find a final, don't we? So basically, we have our 4 variables that we need to make the equation with, right? Now there is such an equation, and it is this one: v squared equals v naught squared plus 2 times a delta d. So here's the equation. This is a timeless acceleration equation. All right. We could go through the derivation, how we got that equation, but I think that'd be like a half an hour of our lives that would be good, well spent, but I think there's better ways to spend it with a looming test. So we'll just go with the equation. What is this v?
Velocity squared.
It is velocity squared, but what velocity is it?
The final velocity.
The final velocity. Right? What is v naught? Initial velocity. What is a? Acceleration. What is delta d? It's a displacement, right? It's a change in position. Okay? It could be the length of the skid marks. Okay? So delta d is a displacement. Now remember though, delta d can also be d final minus d initial. Okay. So we could use this one. They could give us two positions, and we could use this equation as well. Okay. Does that equation make sense?
I guess so.
You guess so? Any questions about that?
Are we gonna have to use it?
Yes. Why would I give it to you if you didn't use it?
Yeah.
Is it timeless like I said?
Yeah.
There's no time quantity in that equation, which is what makes it beneficial.
So this is your favorite test.
It's on your homework. Let's see tomorrow. All right. Some examples. So here's our first example.
Oh,
Let's read. Oh.
okay.
So, a remote controlled car is traveling at a velocity of 2.5 meters per second to the right when it experiences an acceleration of 0.4 meters per second squared to the left for 3 seconds. What is the remote controlled car's final velocity? Now, if you're taking notes on this and you don't want to write that all down, remember you have access to this Prezi, so just put down example 15, and then you'll know where it came from on your Prezi, right? Assuming you access the Prezi on your own.
Which who does that?
What?
Which who does that?
Well, people who want to succeed probably do that. So, if we are going to do a problem like this, then what should we do? I don't know why I put the screen down because I need to write up here. Not good if I can write, isn't it? Thank you, Caleb. I appreciate your plus. Okay. So, what do we know for A? What are some things that we know? Velocity. What's velocity? Okay, is that an initial or final velocity? Initial. That's V naught. Okay. And we said it's to the right, didn't we? Okay, so I have that mirror remote control car.
That's a.
It's like a spaceship.
The Jetson car. Stop poking holes, man. Okay, so we're going to say velocity is that way. That's to the right, isn't it? Okay. Experiencing acceleration to the left, right? So we have an arrow going which way for acceleration? The other way. So then what do I know about my velocity and my acceleration? If this one's positive, then what's this one? Negative. So we would assume which way is positive, right or left?
Right.
So we're calling to the right, positive direction, right?
Yeah.
Okay. So that means our acceleration is Rex with his yap.
I said yup.
Okay. That acceleration is negative. That is very important. Right? What else do we know?
That's a car.
Time. What's time? 3 seconds. What else? What do we want to find? Final velocity, right? So which equation should we use? 6, 7, 8, or 9? And which one? 7. Why 7, Whitney? Because all of these are in equation 7, aren't they? The 3 things I know, and there's only 1 thing I don't know, that's in equation 7. Okay? I couldn't use 8 because 8 has more than 1 thing I don't know. Right? So I got to use 7. So V equals V naught plus AT. Plug things in. V naught was positive 2.5. A was negative 0.4. T was 3 seconds. Hopefully we can see that. Okay. 2.5 plus negative 4 times 3. Right?
Why is there like 2 negatives?
One's a decimal.
Oh,
Good question. Okay. So what do we get? What's our final velocity? Not a lot. It's actually way less than 2.5 because we're slowing down. Remember, velocity, acceleration, opposite directions, we're slowing down.
Don't you gotta enter that?
What'd you say?
Well, 2.5 could be like a lot.
Oh my goodness, this is meters per second. Okay, what is it? 1.3.
Did that in my head.
So, if velocity and acceleration are in opposite directions, the car slows down. Okay, does that make sense? Okay, so this means to the right. All right, I want you to try B. A student driver. Oh, I forgot the R. A student driver. Here, we'll is attempting to talk their way out of a bad road test grade.
Student right
That's like a right angle.
Okay. Is trying to talk their way out of a bad road test grade by explaining that the car was only accelerating at 10 meters per second squared after the light turned green. So he couldn't have been going too fast when I tried to turn 15 seconds after going under the light. How fast was the car going when the student tried to turn?
Just fast.
Okay.
So you were the student,
No, I was not the student.
this is when I tried to.
Right, I guess I should put quotes.
Can I use this booklet?
Better?
Yeah.
You guys and all your English stipulations, I don't like that.
How did you get negative 0.4 for the last one?
Blame Miss Hardy.
Because one velocity is to the right and the acceleration is to the left. So if my velocity is to the right, 2.5 to the right, positive.
Mhm.
You can choose to the right positive. Okay.
Alright.
If to the right's positive, that means to the left is
Negative.
negative. Okay, does that make sense?
No, not at all. I said, how did you get that acceleration for negative 0.4?
Right. Experience the acceleration of 0.4 meters per second squared to the left.
Oh, all right. All right, let's see the to the left.
Gotcha.
You- are you sure?
DC's honest. Now you and Kevin don't have to share anymore.
Thanks, man.
You're welcome. Rex, you doing the problem?
I'm trying to figure out a problem.
Okay, I know some of you might not be done with it yet, but let's make a list. So if we're having a hard time getting started, we can go with the list. So, what do we know? Which velocity, Rex? Initial. What's initial velocity? The car is waiting under the light, and what is the initial velocity going to be? 0. Because typically cars are at rest when under the light. Right? Okay. What else?
This example 16.
15B. What else? Time. What's time?
15.
15 seconds. What else do we know?
We know the acceleration.
Acceleration is
10 meters per second squared.
good, and we want to find V final. Okay, so you are up to that point. Great. Now you guys can figure out which equation to plug in.
Wouldn't it be the same one
What?
as the last one?
There's a glare.
Yeah.
Number 7.
I'm
The hell?
there, like Mr. King.
Can't even.
We were talking about
You didn't get press.
I get it? I get it?
Hey, situation.
Now we know the problem.
You're welcome.
I got the answer. Like he was feeding.
Alright,
That's why I'm good.
so Jameer, what equation should I use? 7? 8? 7, right? V equals V naught plus AT, right?
Yes, sir.
Okay,
Yes, sir.
we don't know V. What's V naught?
0.
0. Now is my A positive or negative?
Positive.
Positive, okay, good. So 10 times
15.
15, right? 10 times 15 is
150.
150 meters per second.
So you don't need the 10 squared.
Yeah, it is.
It's
That's
kind
what
of
I-
fast.
Nope.
69.
It is kind of fast.
Very
Okay.
good.
Been in the corner.
What?
So we going around the corner?
So you explained why I got a bad road test grade, huh?
He was going 150.
He probably slid off the road. Okay?
Brown guy.
Alright,
Leaving that there.
meters per second. Okay,
A
so
lot.
See, we've got to divide by 1,000, right? And multiply by 3,600. So 150 divided by 1,000. Divided by 1,000. Oops. So 0.15 times 3,600.
That's
540 kilometers per hour.
kilometers or miles?
So that's
Kilometers per hour. Yeah.
That's 0.0932.
Nope.
That's like
Yeah.
How many miles?
So 540 kilometers per hour to miles per hour.
Bang, bang.
Or you did 150 meters per second on Google.
How about
How many miles is it? So you're going 0.09 miles per second. Yeah, it's about 50. I think my kilometers per hour calculation might be correct. All right. Does that make sense, though, guys? Guys, does the actual problem make sense? 67. So are you going too fast?
67 around a curve?
Yeah. Yeah.
How do you get that high?
Because they accelerated too much.
Wait,
Okay.
A car, most cars.
Guys, let's not debate the example. You did the problem correctly. You're great. Nice job. Okay. Example 16. At 16A. If the cannon launches the human cannonball from the ground with an upward velocity of 30 meters per second, how long will the human cannonball be in the air for? So, there's the human cannon. Or sorry, there's the human cannonball. Here's the human cannonball launcher. Okay. Launch them upwards at 30 meters per second, right?
Like straight up?
Yep, we're just going to zoom straight up. We're only working one direction right now.
He's gonna die.
No, he won't.
So,
There's a big airbag all surrounding. He's fine.
so,
All right.
If he
So,
goes straight up, he's gonna.
Caleb,
What?
you're taking up your homework time.
Okay.
When we're done with these, you get to work on your homework, right?
Alright.
Okay. If we want to argue the example, we're going to be here all day. Okay. Do it tomorrow. All right. So, what's our initial velocity?
30.
30. Positive or negative?
Shitties.
Positive. What else do we know?
Nothing.
Acceleration is negative 9.8.
Good job, Kevin.
Why is it? Oh,
Because gravity, and we said if the 30 is positive, that means
Gravity has to be negative.
that means down is negative, right? So acceleration is negative 9.8 meters per second squared. Because up was positive, because we said 30 was positive. Okay. What else do we know? Nice. Where does it start?
0.
0, right? So D initial is
0.
0. Okay. Where do we end? 0, because we're hitting the ground again. So D final is 0.
Hey.
What are we trying to find?
Time.
Time.
Oh, is that 9?
So, what equation should we use?
Number 8.
9.
Oh, no, no.
Do we want to know final velocity? No, so 9 isn't it. 8, right? We should use this equation. D equals 1/2 AT squared plus V naught T plus D naught. Right?
Yeah.
Plug in what we know. 0 equals 1/2 times 9.8 negative T squared plus 30T. Right? Plus 0. Does that make sense?
Yes, sir.
That make sense, guys?
Yes, sir.
Yeah? Okay. Now I can simplify some things. We have 0 equals negative 4.9, because half of 9.8 is 4.9.
Is it?
Right? T squared plus 30T. Now some of you are thinking, wait, we have T squared. And you're probably dreading the quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC. All over 2A. Do we need that here, though? No. Because whenever we have an equation like this, we can either quadratic formula or factor. Can I factor this?
No.
Yeah.
What's a common term?
4.
Negative 4.9, yep. What's a common term?
T.
A t,
Oh.
How'd you get negative?
right?
Come on.
I can take a t out of both.
You can't take anything else out of it?
Nope.
Are you sure?
Well, you could, but leave more decimals for 4.9.
Alright.
Okay.
Just making sure.
When did we learn this? 10th grade math, which you are in right now. Okay.
I don't
So, we can factor a t out of both, right?
I'm not-
Right? You should have been, or you would have been before. Okay.
What?
Well, you should.
I don't remember anything. from
Okay.
yesterday. I've been twice.
So, now I have two factors, right?
Yeah.
If I want to find when this equals 0, that means we set our two factors equal to 0. So 1 t equals 0. Great. The human cannonball's on the ground when it gets started. Wonderful. That's what we expected, right?
Yep.
Okay. The other one, 0 equals negative 4.9 t plus 30. How do I solve this?
Oh, that's a 30. I thought that was a
Subtract 30, right? So we have negative 30 equals negative 4.9 t. What do I do now?
Divided by 4.9.
Divide by negative 4.9.
Yeah, like 600.
30 divided by negative 4.9, what do we get? Positive 6 point something. You guys have calculators. It's amazing me that you don't punch it in.
I don't.
5 buttons, 6 buttons. What is it? 6.1 seconds equals time. Thank you, Sandra. Who else said that? Michael? Amani? Rex?
G1.
It was on.
Okay. Does that make sense, guys?
Ah.
Rex says yeah. I want you guys to try B. Okay?
I could do
So for B, if the cannon is placed on a 5-meter high platform, how far off the ground is the human cannonball when t is 2 and t is 5? Okay? So, make a list. The list will probably look similar to the one we started with. Okay? Except what things are changing in this list.
the height.
What height?
The height at which you start.
The height at which we start, right? What's the height at which we start?
5 meters.
5 meters. Okay? What else changes? Time is? Okay.
2 and 5.
2 seconds the first time, right?
And then 5 seconds.
And then 5 seconds the second time.
And then 8 seconds.
Oh, there's no 8 seconds. Okay. Alright. What are we trying to find? The height. So we're trying to find the final position, right? Same equation or different one? Same equation. Can you guys find those heights?
Theoretically.
Theoretically. Rex, you are running the key phrases today, aren't you?
Yeah.
All of your signature one-liners, you're running through them all today. Yop. Theoretically. I don't know what's going to happen next.
I haven't said my few.
You haven't said, well, you just did. So, plug them in, Reggie. I know you're not working on what I have because you have the review in front of you, no line paper. Okay? And you're talking about vocabulary.
Oh God.
Okay? So please work on what I'm working on. Guys, this is to prepare you for your homework that's due tomorrow and for your test on Tuesday.
So our test is going to be like a first grade in the new market.
It will be. Get off to a good start.
No.
Actually, your review will be your first grade.
Oh, okay. So A in the next.
You'll have an A for like 30 minutes. When I put the review in
But
my
it takes
taking
you
your
like
test.
3 years to grade test.
Yeah.
So I'm going to have an A for 3 years.
That'll work out.
Are we gonna have to remember these equations or not?
I will give you a list of the equations. All right. So what are the two problems I need to solve here? You gotta plug in a number twice.
You know, it's a struggle.
Okay. So the first one, I plug in all these numbers with what for t?
2.
2. So we solve this. D equals 1/2 times negative 9.8, 2 squared, right? Plus 30 times 2 plus 5. Right? If we do that, what do we get?
45.
What is it?
45.4.
45.4 meters. That's how high we are off the ground, right? The reason why it's off the ground is because we said our initial position was 5. Okay? If we didn't have this initial position of 5, then our answer would be 40.4, and that's how high we'd be above the platform. All right. Well, good job.
How do we know that you're not lying to us about this and this isn't just one sick, twisted game of yours to mess up our future?
Oh, I'm not here to mess futures up. Okay, what's the other equation? The same thing, except what changes?
The time to
The 2 becomes a 5. Jameer, practice these problems. Okay? All right, and stop talking to Jose.
I'm talking to Caleb.
Caleb, stop distracting Jameer.
I'm just sitting here.
Can't speak on this language.
Oh, goodness. He speaks English.
Did you hear that?
Okay. No, I didn't hear that.
Did
I'll
you
talk
guys
to Caleb about it later.
the equation?
No.
Okay, so we plug in, what do we get?
32.5.
What is it, Michael?
32.5.
32.5.
I got that.
You're confused, Katrina?
No.
Make sense now?
Yeah.
Okay, so I use all of these and plug them in right here.
And then you did that, you got that.
Yeah. And then we use 5 later.
Oh, so you had to do
Okay.
it twice.
Yep, we do the same thing twice. Okay. Any questions? Last one. Oh, you had a question?
Oh
told
my
us 2
God.
is 45, not 7. You really
What?
did.
No, he actually said 6.
45? Right here? Okay, do you understand how I got the list? Okay, we use the time of 2. Okay? Don't forget that this 9.8 is negative, and the 2 is squared. Okay, did you do that or no? Okay.
How many questions like this is there gonna be?
We only have an hour. So, let's see. Average about a minute a question, about 60 of them.
Yeah.
We don't
Okay, maybe 10 questions, Katrina.
Man, maybe 10? That's too much.
Like
That's crazy.
this was like one question.
Are you serious?
It'll take you the whole hour.
So this is all we're doing for the test?
No, maybe 10 total questions of everything we've done.
Oh.
So like the graph stuff, and
I'm
then.
saying, do we have to do 10 of these long?
Oh no, not 10 of these questions.
Oh,
Yeah,
okay. So just like one of these, 2?
Well, I like to make sure that every equation gets its time in the sun.
Oh, no.
Okay, so
So like
you're going to need to know how to use every equation at least once.
But they're all the same.
Now,
I know how to
could that be in multiple questions, or could there be multiple equations in one question? Yes, but you need the reason why we have those 9 equations. It kind of gives you a list of what we need to know.
So if we don't use one, we did something wrong.
Or you found a way to do the problem that I didn't expect.
Um,
Like if you combine 2 equations to do a problem versus just using one. All right, last one. I said 3 examples, 2 questions per example, guys. 3 times 2 is 6. So I gave you what I said. All right. While surveying a near accident scene, a police officer tries to give you a ticket for speeding because the skid marks you left on the pavement were 8.3 meters long, and the maximum braking acceleration of your car is 5.2 meters per second squared. So given the size of your car and the type of brakes, all right? If the speed limit was 15 meters per second, is the police officer justified in giving you a ticket?
Did he see
Okay.
it?
Well, let's make a list of what we know. Was the police officer there? No. The police officer did not time the situation. Okay?
How does he know you left them so much?
Because they're underneath your tires.
How do you know you have good brakes?
Okay. By looking at them.
You can't just.
All right.
Yeah, he doesn't have the right to look.
You have to take them apart.
Guys,
Just have to have them warned.
Once again, you're using up your homework time by arguing the example with me. Okay. So, what do we know?
Velocity. Or,
we
yeah.
know acceleration.
Okay.
You know the displacement?
Acceleration is 5.2 meters per second squared. Now, is this acceleration speeding the car up or slowing the car down?
Slowing the car down.
Slowing the car down. So is it positive or negative acceleration?
Negative.
Negative. We're assuming the car's direction of travel is positive, right? So it's a negative 5.2 meters per second squared. Bless you. Okay. They're in reverse. Well, it's still that it'd be negative then. Okay. All right. What else we know?
We know the displacement.
The displacement, right?
Yeah.
So is that D initial, D final, or is that change in D? Change. So that's delta D, right?
Yeah.
Okay.
That's 8.3.
And it's positive because it's going in the same direction the car is going. What else? Which velocity? Okay, that's the speed limit, right? Is that necessarily how fast the car was going? No. So that's for comparing later, but there is a velocity we do know. Which one is that? Final. Good job, Reggie. So V final is 0 meters per second. What are we trying to find?
The initial.
The initial, right? Or V naught. Okay. So, which equation should we use? 7, 8, or 9? 9. Okay. So equation 9 tells you that V squared equals V naught squared plus 2A delta D.
Does it now?
It does.
Which equation?
That's number 9. I haven't put it up there yet because we just learned it today. Okay. So let's plug in what we know. Okay. So we have 0 squared equals V naught squared plus 2 times negative 5.2 times 8.3. Okay. Can we figure out our V initial? 9, you deep in thought? Okay. I'll do the left side. And I'll even do the first part of the right side. I'm so helpful.
Alright, I got the back.
So what's that second part?
Hold on, I got you.
Not that much.
Hold on. Negative 86 point. Is that right?
Negative 86 point what?
3.2.
I thought you
3,
said-
2.
Hey, get off me.
Okay. Now, the negative sign is very important because if I'm going to solve this, I have to move this to the other side, right? If I didn't have my negative sign in here, I'd end up with a negative. Can I square root a negative? No. Okay?
Oh, no.
So if you end up square rooting a negative, then you probably forgot a negative sign somewhere else. You're going to want to try to find that negative sign. Jameer, leave Katrina alone. Okay. Okay. So, now what?
Hold on. Let me
Switch sides. How do I switch sides?
subtract it. Subtract it.
We add.
Oh, yeah, add it.
Way to use add and not plus.
I said plus.
Oh man, it's like a third grader. So 86.32, not to offend all third graders out there.
Well, you are my math teacher.
I know, I hate when people say plus. Okay, so now what do I do?
You square root that.
We square root.
Yep, you get it.
Square root of 86.32, what do we get? 9.29. So does the police officer have any reason to give you a speeding ticket?
Yeah.
No. Could they give you a ticket for texting while driving?
Yeah.
Well, the problem doesn't say so, but it's likely. I'm just joking. Don't text while driving. Any questions about that problem? Any questions?
Now we have
Okay.
to do B.
Try B.
So, can you erase everything so I don't get distracted?
You are wow.
Yes, I can. And look, Caleb, no marks.
You got a new one?
All right, so
No, I haven't. Many eraser marks.
I can get you some whiteout, you know.
And
I could put some white tape over it too. I'll try it. But I've heard people trying that before, but then they get a pink spot.
What?
It's really like a little like spot. We'll try some. What's okay? Or I could do this. You ready?
you're so cool.
No, it's not. It's just long enough.
You are the
Being a short guy like yourself, it's just enough.
You're as tall as I am.
I know. Hey, we all can't be hobbits. All right, so B, you are designing a new highway on-ramp, and you are trying to figure out how long to make the ramp. You anticipate that cars entering the ramp will have a velocity of 5 meters per second and need to reach a velocity of 35 meters per second before leaving the ramp. If a reasonable acceleration for a car is 2.5 meters per second squared, how long should you make the on-ramp?
Just like
Nice, Rex. Always so literal.
I do not think I want to be.
I always
So make a list. Figure out which equation to
On the
use.
test, you're gonna have to put like, what's the answer specified?
Well, Rex, this is a physics class, so I'll be grading your ability to do physics. So if you say just long enough, your sarcasm is impeccable, but this is not a sarcasm class. Your sarcasm grade would be an A.
Do they have that? Because that'd be a class that I could do.
They do, and Miss Hardy teaches it.
Really?
No, that was sarcastic.
You guys can.
You were failing.
Yeah, you failed sarcasm class.
Don't touch him.
Go back.
Make a list.
I have a list, but
My face is funny.
it's like a small list.
Yeah.
I can't figure out the equation.
All right, we'll take a look at it in a second because that is homework, not classwork.
My face is funny.
Yep.
It did.
What?
It's
What's
funny.
the question? No. Yes, yes, you're
My face funny.
You're looking for
That's
this.
what you have to do.
Your lips chapped.
They
They
over here
did.
that.
It is.
Guys, work on the example. We done?
Action.
Kyle, you done?
No.
Okay, then finish up. Good job, Jose. Caleb.
Almost did a video, almost had to grab something. Life of it.
Stop calling me that. Yeah, man. You gotta tell them my real name.
Oh.
Yep. What's that?
Do you have to grade 35 and 5?
What?
Yes. 35 and 5 is displacement. Yes, squared.
Yes.
Remember that really catchy song you played us last year about space?
I do not.
It was like Symphony of Sound, Symphony of the Stars.
Oh yeah, I do remember that.
Yeah.
All right, guys. So, what do we know?
Initial velocity.
Okay, initial velocity. What's initial velocity? 5 meters per second. What else do we know?
Final.
Final velocity is
35.
35 meters per second, right?
Yeah.
What else? What else?
Acceleration.
Acceleration is.
2.5 is second squared.
Now, is this acceleration positive or negative? Why?
Net record.
Good. We're going faster. I appreciate your enthusiasm there, Caleb. Okay. We're increasing speed, right? What else do we know? That's it. What are we trying to find? The displacement, the change in position, right? So, what equation should I use for this one?
All of them.
Number 9.
All of them simultaneously, right?
Number 8.
Okay. Which one?
Wait, no, number 9.
Number 9?
I'm thinking.
So, v squared equals v naught squared plus 2a delta d?
Yup.
Yeah.
That's it.
Okay. So we'll plug in what I know. We have 35 squared equals 5 squared plus 2 times 2.5 delta d. You know, this time I'll do the right side. Since I did the left side last time, I'll do the right side this time. You guys do the left side. So 5 squared, I know that's 25. Plus 2 times 2, 5. Okay. Everybody have the left side worked out?
It's 1,000.
1,225.
Nice one, guys.
1225. Nice job, guys. Thank you, Kyle. Okay. Now what?
Add the 25 and 5 together.
No, we can't do that because this is a variable.
Subtract it.
Okay.
1,200
The 1200 equals 5 delta d.
divided by 5.
Divided by 5.
240.
240. Do I need to square root it now?
No.
No.
Probably not.
So the on ramp should be 240 meters long.
You should.
They should make it just a little bit longer, just a couple.
It's probably a good idea. They'd probably overdo that. Probably go like 300 then.
Yeah.
All right. All right. Does that make sense, guys?